Okay, students, we're going to go ahead and go through the Algebra 1. This is school year 2021. Okay, it says the table shows the dimension of a right rectangular prism. This you're going to do in geometry as well in Mod 3. Represented by these algebraic expressions. So you're actually going to do this problem, just different numbers, in a test and assignment on Mod 3. Okay, so you can see you had it in Algebra 1, just multiplying binomials together, because we know the volume for a rectangular prism is length times width times height. And they give you length, width, and height. So you just multiply all three of these together. Well, you only can multiply two at a time. Okay, so you do two at a time. We'll go ahead and do it right up here. 3x plus 1. I do the vertical method, x plus 4. You put it in standard form, which means highest degree down. That way they'll line up their like terms when you multiply like you did in elementary school. 1 times 4 is 4, positive 4. 4 times 3x is 12x. You can put the plus sign with it. Then you cross, like you did in elementary school, like if you did 12 times 23, okay? X times 1 is 1x, and x times 3x is 3x squared. And I just add straight down. So notice it lines up my like terms right now. So I have 3x squared plus 13x plus 4. Well, now I have to take that answer and multiply by the last one, 2x minus 2. So put the 2x minus 2 here, do the same steps again. That's negative 8. That gives me negative 26x. That gives me negative 6x squared. Then 2x times 4 is positive 8x. Put the sign with it. Plus 26x squared right there, and plus 6x cubed. And add straight down, I get 6x cubed because they're like terms. 26 minus 6 is plus 20x squared. 8 minus 26 is negative 18x, and minus 8. There's my answers. Now I go ahead and look for that. 6x cubed plus 20x minus 9, right there. There it is, right there. Okay. So again, you need to know this for geometry class. If you're watching this in algebra class, you're going to do the same problem. There's different numbers again in geometry. So you better learn how to multiply binomials together. Okay, I'm going to go ahead and erase that so you can do the next problem. Number 2, two binomials are defined as shown. Remember, this is just function notation. It's really no different than saying y too much, except for a function must pass the vertical line test when you graph it. So you know that's what's going to happen when you graph this. So therefore, it can't be a vertical line at all because that would fail the vertical line test because it crosses all the time. And vertical line test says if I have an equation, I have some graph, if I draw any vertical line through it, it's only going to touch one time. That's the vertical line test. It must pass that. So here we have a quadratic, which is a parabola. It opens up because a here is positive. So if I draw any vertical line through, it's only going to touch one time. So it's a function. That's why you can write it in function notation. The name of the function is p. So it would be called the p function if they ever ask that. This is called the independent variable, and it's got to be the same variable as what you see on this right side. So for example, if these were y's here, then this should have to be p of y. Okay, it's got to be the exact same variable, just so you know this. All right, so it says which expression represents p of x times r of x. So just multiply the two together, that's it. Again, it's basically just like this here, except for I have a trinomial times a binomial. So again, line it up. Multiply negative 5, positive 2x, and positive 1x squared. Then I have positive 15x, because the negative times negative is positive, negative 6x squared, and negative 3x cubed. They're all lined up. Go straight down, add them straight down. 3x cubed. 1 minus 6 is negative 5x squared plus 17x minus 5. So I'm looking for that answer. There it is, C again. Wow, that's not too smart and put it C, because a lot of you will guess C. Okay, what's the product? Here we have multiplication again. Okay, 3 of these problems. This is ridiculous to have this many of the same type. Just multiplying things together, okay? You covered a lot more stuff than this, okay? It's no different, just multiply. So I have negative 3 plus 3x minus 3x squared. I have 2x squared times 1 is 2x squared. I have to line it up on the x squareds. Then I have 2x squared times x squared is 2x to the fourth. I can't get that over there. So I have 2x to the fourth. Negative 3 plus 2 is negative 1x squared plus 3x minus 3. And all I'm doing is putting these coefficients in, so I drop it down. 2 goes there. Negative 1 goes there. 3. Oh, there is no. Oh, hold on here. I skipped one. Dang it. All right, I gotta do this again. I skipped a term, and I'll move it over so we can get it all together. And so I have to try to scrunch things. That's probably what I have. I'm trying to scrunch it. 2x squared. Right, the trinomial at top. X squared minus x plus 1. 2x squared minus 3. So yeah, minus 3 plus 3x minus 3x squared. Then I have 2x squared times 1 is 2x squared. So it goes underneath the x squareds. Then I have 2x squared times negative 1, which is negative 2x cubed. And then I have 2 times 1 is 2x to the fourth. Now add straight down. I got all my room there. Okay, now again, then the 2 goes here, negative 2 there, negative 1 there, 3 there, and negative 3 there. Just dragging them down there. Okay, got to line up your like terms. Okay, again, this one you had a little more because you have more different terms involved in there. So I want to see if you could line up like terms, but still multiplication of polynomials. All right. So this must have been what Ms. White typed in herself, I think. Okay, if the functions f and g are identified as that and this, so there's the f of x, there's the g of x, which expression is equivalent to g of x minus? So you're subtracting the two polynomials. Okay, but what you have to do first is you have to square this out. Now, the shortcut that you should learn is square the first term, x, I don't need the parentheses, x squared, multiply the two terms together, it gives me negative 3x and double that, negative 6x, and negative 3 times negative 3 is plus 9, and then you have a minus 1. Okay, well that's going to give you x squared minus 6x plus 8, right? Okay, and then it says, oh, okay, here's the other tricky part, is you have to make sure you put it in the right order. So this is on the bottom. We're subtracting this right here. I'll write it down here. Minus x squared minus 6x plus 8. Okay, you have to make sure you pay attention to order. Remember, subtraction, order matters. G of x. So I now have 2x squared minus 5x plus 6. Now what happens when I subtract? I have to distribute that negative 1 through, and which then what does that do? It changes all the signs. So that becomes negative, that becomes negative, positive, and that becomes negative. Okay, then I can get rid of that. I distribute the negative 1 through there. So 2x squared minus 1x squared is 1x squared. Negative 5 plus 6 is plus 1x. And 6 minus 8 is negative 2. There's my answer. So I look for it. X squared plus x minus 2. A. Okay, number 5. Check the order of terms. Okay, that's her. Okay, the expression can be written as k times this. What's the value of k? Well, what's the very first thing you do when you see a polynomial? You factor out the GCF. Okay. Now notice they switch the order here, so I have to pay attention to the order. So they have negative 80, they put the x squared first. 3x minus 63xy, and then plus 42y. Okay, now what we're doing is factoring out the GCF. Well, this should be fairly simple because all I have to do is see I have to have a negative 2y there, for example. This has to be negative 2. Well, how do I get negative 2 from 42? I divide by what? Negative 21. 42 divided by negative 21 is negative 2. And I can check that with the other. What's negative 84 divided by negative 21? Positive 4, right there. What's negative 63 divided by negative 21? Positive 3, right there. So I can easily check that. So they're checking to see, in this case, GCF. Now, if this was in the calculator, you could actually have the calculator do the GCF for you. You can only do 2 at a time. Now, here's another helpful hint on GCS with numbers. Okay, the highest the GCF, if I look at these 3 numbers, the highest the GCF can be, and ignore the negative signs and positive signs, just the number itself. Forget the negative. The highest the GCF could ever be is the smallest difference between any 2 of them. So what is 84 minus 63? That's 21. And obviously 84 minus 42 is even bigger. What's 63 minus 42? Oh, that's 21. Well, that's going to tell me right there that it's probably 21. But the greatest the GCF could be is 21. It's going to be 21 or less. So that's just another helpful hint as far as GCFs are concerned. Okay. And like I said, you can then see 21 times 2, 21 times 3, and 21 times 4. And then I had to change and check the sign. So it had to be negative. So normally you're not taking out the negative, but in this case you are because you have to make it fit what they want it to fit. So the answer is negative 21. Okay. The expression is shown. Which expression shows the original expression factored completely? So I want to factor that completely. First step in factoring, factor out the GCF. Greatest common factor. Step 2, factor what's left if possible. Factor what's left, which means inside the parentheses, if possible. You already took out the GCF, hopefully. Okay, so what is the GCF between 6 and 54? It's 6. Is there an x in common? Yes, there is. How many x's? Only 1, so I can only take out 1 x of them. So I take out 6x from 6x cubed, and I'm left with x squared. Now, if you're not sure what that is, all you do is you divide each term by that GCF. So 6x cubed divided by 6x is x squared, and then I get negative 9. So that's step 1. It's only step 1, factor out the GCF. Step 2, factor what's left inside parentheses if possible. I should see I have a binomial. When I have a binomial, the very first thing I'm looking for is difference of perfect squares or difference of squares. Do I have a different sign there? Yes, I do. Difference means subtraction. There's my difference sign. Are both of these perfect squares? Yes, they are. X squared is x times x, and 9 is 3 times 3. So that's going to factor into a difference of perfect squares. So it's x minus 3. I just take the square root of each, and one's a plus and one's a minus. So there's your answer right there, which is D. Okay. So here, B, they only did step 1. Notice that's only step 1. Only step 1. They did not factor what's left inside the parentheses if possible. You have to be able to recognize that as a difference of perfect squares. All right, part B. What number is the greatest monomial factor of this expression when factored completely? So monomial factor, mon means 1. Factor means it divides into it evenly. So what this is basically asking, the greatest GCF. What's the GCF? Okay. So obviously the greatest it can be is 4 if with the numbers. Okay. What number is the greatest common? Well, factor this first one factored completely. Uh, oh, so first I need to combine like terms. Combine like terms. 26x squared plus 4x squared is 30x squared. 53 minus 128 is negative 75. Okay, so now I have that. So first, normally it's already combined like terms, but in this case it wasn't. So I guess you can say step one would be combine like terms. Okay, now what's the GCF between 30 and 75? 15 is. 15. Can I take out an x from either? No, only, so it's 15. I have 2x squared minus 5. Okay, so the monomial factor ah, here's where it's tricky. So this is uh, okay. Monomial is gotta be part of a polynomial, which means it has to have an x in it. So then this is gonna be your answer, I believe. Whew, I can't believe you throw that on there. This is your GCF. Okay. Uh, with monomial, is a polynomial. Uh, one term of polynomial, which means it has to have an x in it, which would be then 2x squared minus 5. I can't believe they throw that on there like that. If they should have asked what's the GCF, and then it'd be 15. I don't think I've ever seen a question asked that right there like that before. Okay, because I would have just automatically thought GCF 15. Okay. Solve equations for a variable. The equation shows which equation represents the value of x. So what it's saying to solve for x? How do we solve all equations? Reverse PEMDAS. So I add abstract across. First, subtract the p across. So now I'm at 1/2 h x squared equals k minus p, capital P. Okay, this is all multiplied together times x squared, so opposite multiplication is division. Okay, and dividing by 1/2 is the same as multiplying by 2. So I have this times 2 over h. 2 over h will cancel that out. The h's cancel, the g's cancel. Okay, so now I have this equals x squared. How do I go from x now up to exponents? How do I go from x squared down to x? I take the square root. Okay, so this is the answer right here. I'm looking for one that looks like this. Notice I have 2 times k minus the quantity k minus p over h square root. So it's C right there. Reverse PEMDAS. Okay, that's a pretty tough one for an algebra 1. That's often more at an algebra 2 level. Okay, number 8. The amount of money a homeowner can borrow from a bank can be determined by this. Okay. For the equation, what's the value of x in terms of a? So again, it's the same type of question. When it says value of x in terms of a, it just means solve for x. Okay, when it says in terms of A, that means A must be in the answer. Whenever it says in terms of, that whatever that is there, A must be in the answer. Okay, so we're just solving for X. Add the 13 across, you get AX equals 13 minus 3 is 10. Last step, divide by A. So it's 10 over A. That's more of an Algebra 1 level 1 right there. Simple enough right there. The other one was tougher. Okay. All right, next one. Which graph represents a set of all solutions? So this is standard form. Remember, AX plus BY equals C is standard form. You need to know your vocabulary. Okay, A, B, and C are integers, not fractions, and A is greater than 0. That's the conditions for standard form. Okay, now I want you to graph it. I could just solve this for y, which means I'm going to add the y across here and subtract the 8 across. I get y equals 3x minus 8. So the y-intercept is negative 8 right there, which wipes out this, wipes out these ones. And it's a line, so it's not this right here. And I could just go up 3, right 1, up 3, right 1, up 3, right 1. Okay, and there it is. Should be simple enough right there. All right, next one, graph the set of solutions for this one. To graph a line, select 2 points on the coordinate plane. Okay, a line will be drawn through those 2 points. Okay, so in standard form, the 2 easiest points to plot are the x and y intercepts. 2 easiest points to plot in standard form are the x and y intercepts. You should know that. I'm writing it down for those of you who have forgotten. That should be memorized already. So x-intercept is when y equals 0. So if y equals 0, that means cover up the y, it's gone. 3x equals 6, x equals 2. That's the x-intercept. Okay, the y-intercept is when x equals 0. Plug in 0 for the x, so that's gone. Negative 2y equals 6, y equals negative 3. So 2, 0, I'd pick, and 0, negative 3, I'd pick. And then it would connect the line for you, it says. And there's your line. So select 2 points in the coordinate plane. Those are the 2 points we're going to pick. X and Y intercepts. Should be easy. Okay. Now we're graphing inequalities. System of inequalities here. Again, standard forms, I'm going to use the X and Y intercepts to get my lines. Now what I have to remember is those are both dotted now or dashed because there's no equal sign at the bottom. So both are dashed. So I'm going to be picking the dash on both lines right there. Okay. Let me go ahead and graph the line itself first. So here we have x-intercept is 2, 0. Y-intercept is when x is 0, and you get negative 3. So 2, 0, and 0, negative 3. Okay, and remember that's going to be dashed like that. And here, x-intercept is 4, and y-intercept is 2. Let's change the color. 4, 0, 1, 2, 3, 4, 0, and 0, 2. And it's going to be dashed. Okay, you just pick the dash there. Okay, so now the question is, which way do I shade? Okay, when I'm looking at in standard form, I look at the y coefficient. If the y coefficient is positive, as it is here, I keep that same sign, greater than. Okay, so this is line 2, line 1, line 2, line 1. So on line 2, I'm shading above. Okay, which should be up here. Okay, on line 1, since that coefficient on the y, and I don't care about the x on the y, if that's negative as it is, I have to switch the inequality sign. So it becomes greater than. So I'm shading above on the green. There's above on the green. Now, where does it overlap? Where is it both green and red? Right here. And there's my answer. Okay. Now I can guarantee I'm right by picking any point in this region, and it will be true for both of those inequalities. I plug it back in, and it will end up being true. So I could pick 0, 3, for example. 0, 3 is -6 less than 6. Yes, it is. 0, 3. 4 times 3 is 12. Is 12 greater than 8? Yes, it is. Okay. So that tells me I could check it that way as well. Okay, now you could have also solved each inequality for y if you wanted to, and put it in slope-intercept form and graph that way too. Part A, which graph represents cost and revenue equations in a coordinate plane? Was there something? Oh, right here, 14. Okay, cost manufactures a certain item and sells it online. The company has a business model where the cost, C in dollars, that's usually what it does in cost, as you see, to make X items by the equation this. The revenue R in dollars is made by selling X items, is given by the equation R equals 10X. So there's my two equations. Okay, that's like Y equals, and that's like Y equals. Okay, so it says, part A, which graph represents the cost and revenue equations? So which are the two graphs here? Okay, you got to have a y-intercept. So this one is 10x plus 0, right? So at 0, 0, I go up 10. If I go up, well, here's 5 right here. So I plug in 5 for x, that gives me 50. 550. There it is right there. So that works. Okay, so that's going to be that one right here. Okay, so that has to be there. So that wipes out on here, it wipes out this one. Okay, now the other one is starts at 50. Well, that doesn't start at 50, so it wipes out that one. This one starts at 50, but it's a horizontal line. That'd be y equals 50. So that can't be it, because it doesn't say y equals 50. And so therefore, this is my answer right here at 50, and I go up 20/3 each time. Okay, so I can use quick process of elimination right there. All right, let's see. Part B, how many items must the company sell in order for the cost to equal the revenue? So that means where it intersects. So again, we have to use the right graph. So it's this right here. So it intersects right there. So at 15 items, it will cost $150. That's when revenue and costs equal the same. So 15, real easy right there, point of intersection. Okay, next. Okay, this is the one that has all the parts. Okay, let's do 16 first, and then we'll come back to 15. So when you see like part A, B, C, D, I would do that one last, always, all those parts to it. Do the others first. So linear equation is this, where A and B are positive. Identify which quadrants must contain the solutions to the equation. Okay, A and B are both positive. So the example would be y equals 1x plus 1. Is graphing x, right? Identify which quadrants must contain solutions to the equation. So y equals x plus 1. Right there. What quadrants is that in? 1, 2, and 3. Okay, so quadrant 1, we write them in Roman numerals. 1, 2, and 3. A second linear equation of the form this, where C and D are both negative. So I put that in there, y equals negative 1x minus 1. Identify the quadrants which contain this equation. So y equals negative x minus 1. It's going to look like this. I'll change the color. Okay, so that's quadrants 2, 3, 4. 2, 3, and 4. Do the two lines intersect? Yes, they do right there. Okay, that's an example. So describe the location of their intersection. Okay. Well, what we can say is it's going to be either, well, you can say it's going to be to the left of the y-axis. It's got to be over here somewhere. It could be up in quadrant 2. Obviously, this one is right on the x-axis, and or it could be down here in quadrant 3. So it depends on what your values are. Enter your answers and justify the space provided. So that's what I would say. It could be in quadrant 2, 3, or 4. 2 or 3. Quadrants 2 or 3 only. 2 or 3 or on x-axis between quads 2 and 3. So it can't be you can't just say x-axis because this is the x-axis over here as well. It's not over there. It's between quadrants 2 and 3 on the x-axis. Okay. And that's going to depend on what A, B, C, and D are. Okay, so that'd be that answer. Okay. All right, now let's go back on 15 here. Miss White said she didn't like even looking at all this reading and to deal with it. Okay. Contractor employs master painters and apprentice painters. The master painter is paid more and paints more square footage in an 8-hour work day than an apprentice painter. The table shows the estimated workload for each of the painters and the 2 rates for painting costs per work day. Okay. Part A, the contractor has a 1-day job for a customer who receives the discounted rate. The customer wants only 2 master painters. Gets the discounted rate, 2 master painters on the job, and can pay no more than $17.50 for a work day. So that's going to be cost per work day. How many more apprentices can work? So 2 times that, going to be 2 of those, $400 for the master painters. No more than, so that means less than or equal to $17.50 total. Only 2 master painters. So that's $400 for the work day for the master painters because they got the discounted rate. It's going to be discounted for that. Okay. How many more apprentices can work at the customer's discounted rate? So I have 80x equals, I have to subtract off this 400 that I paid to the master painter. It's $13.50 equals $13.50. So those cancel out. 8 goes into 13 one time. I'm left with 55. That's almost 7. So it's 0.6 almost like 8 or 9. Okay. So I can only have 16 because I can't afford the 17th one. So I can have 16 right there, master painters. Okay, so there's part A. All right, part B. The contractor is hired for a job that pays the customary rate. Okay, here's the customary rate. One's right here. The job requires painting at least 2,000 square feet of wall space and at least 1,200 square feet of trim. And, okay, so we're doing wall and trim, right? Because we want at least 2,000 square feet of wall space and 1,200 of trim. Which statement is true about the combination of master painters and apprentice painters needed to complete this job in one work day for less than $1,550? Okay, so we look at these combinations and see what it's going to cost. A combination of 2 master painters and 10 apprentices. Okay, 2 master painters. Excuse me. Okay, so 2 master painters. You get 1,000 square feet for the wall and 200 for the trim. Okay, and that would be $500. Okay, 10 apprentices. 10 apprentices, we got 1,000 each. 1,000 here and 1,000 here. And 10 times that is 1,000. Okay, so that'd be 1,500, which is less than the 1,550. And let's see, so this is a total of 2,000, and this is a total of 1,200. And that fits it. Okay, so I could actually just stop right there because it doesn't say, it doesn't say select all that are true, and then I have to go through each one. Since this first one worked, okay, then I can stop right there. Okay, C now. Where's C? Part C. On a one workday job done at the customary rate, the number of master painters must be exactly half the number of apprentice painters. So master, apprentice, 2x, x, half of it, 2 times it. Okay. If the cost of the job is between $1,000 and $6,000, so anywhere in between there, what is the constraint on the number of master painters and apprentice painters? Okay. And it's at the customary rate. Okay. Number must be exactly half. Okay. So at least 3, but no more than 13 master painters. Okay, at least 5, but no more than 26 master painters. More than 2 master painters, fewer than 13, fewer than 26, more than that, at least 3, no more than 13 apprentices, and more than 404, but no more than 26 apprentices. Okay, so this is an awful lot more work here. Okay. So what was, okay, if the cost of the job is between 1,000 and 6,000. Okay. So if I did customer rate, okay. So I have 250 X, we call this X, let's just plug numbers in here. Okay, so 250, if I go, so notice at least 3. If I go 3 master painters, that is $750. Master. Now, if I do 3, that means there has to be 6 apprentice. And 6 apprentice is be 600. So that's 1,350 right there. So that's more than 1,000. Okay. So that is true. But no more than 13 master painters. Now, if I say you have to have 13 master painters, 13 times 250, that means I have to have 26 times 100. So let's pull up the graphing calculator here. Okay, let's see if I can pull that off to the side over here. Let's move this over here. Okay, I said, okay, 13 times 250. 13 times 250 plus what was it? 2,600. It's 5,850. That works. Okay. But no more than 13. Because if I go, that's going to be true. So I go one more. If I did 14, that's going to be 20. That's going to put me over. So that's true. At least 5, but no more than 26 master painters. I can't have that at all. I can't go more than 13 master painters. We just saw that. That put it almost at 6,000 right there. Okay. So it can't be more than 13 master painters. More than 2 master painters. Select all that apply. More than 2. Fewer than 13. Well, 13 actually works. But more than 2, um, fewer than 26 apprentices. No, because 26 works. Okay, that one will work right there. So fewer than 26 apprentices. Um, okay, so the trick part here is um, more than 4 apprentices. That's also going to be true, but it doesn't give you a max amount. So I'm thinking that means it can go all the way down, which doesn't make sense then. At least 3, but no more than 13 apprentices. No. So if I do no more than 13, so at least 3. So if I do 3 apprentices, that means 1.5 masters. You can't have 1.5 masters. So that would not make sense. You can't have 1.5 masters because it has to be exactly half of it. More than 4, but no more than 26 apprentices. Okay. So more than 4, so I put it at 5. It can't be 5. It has to be 6 apprentices, and that'd be 3 masters. So let's see if that gives me um, 1,000. I have to have at least 1,000 there. 600 and 3 masters is 750 plus the 600. Yes. Okay. So more than 4. So 6 apprentices, but no more than 26. 26 maxes out. Yes. So this is true right here. Okay. So these two are saying basically the same thing right there. Those two would be your answers, I would say, right there. Okay. This can't be. Okay. This is more than 2, but it doesn't tell you it can have as many as you want. Okay. So that's why I'd wipe out all of these right here. I would just say those two. All right. That's part C. Part D now. Oops. Okay, the contractor needs to determine the number of master painters and the number of apprentice painters to use for another job. The job requires painting wall space measuring at least 2,500 square feet, but no more than 4,000 square feet, as well as trim measuring. So that's wall space. Wall space is between 2,500 and 4,000. Okay, as well as trim measuring at least 600 feet, but no more than 1,500. So those two conditions, all in one workday. The master painters and apprentices, okay, apprentice painters will paint both the walls and the trim. So we're using that combination. Which combination of painters satisfies the situation? Select all that apply. Okay, so 2 master painters and 25 apprentices. You gotta see if that, so 2 master painters is 2 master gives me 1,000 wall and 200 trim. Okay, and 10 apprentices. No, that's part B. Where was it down here? 2 masters and 25 apprentices. 25 apprentices gives me 2,500 of each. Okay, 2,500 of each. So that gives me 3,500. Okay, and I needed it to be, and that's within it for a while, and that gives me 2,700 for trim. 2,700 is way too high, so that's out. 3 master painters and 3 apprentices. Okay, so 3 master. Let's just get rid of this now. 3 master. Showing this again. 3 master gives me 1,500 wall and 300 trim. That's for 3 master and 3 apprentice. 3 apprentice gives me 300 and 300. So that gives me 600, satisfy the minimum, and that gives me 1,800. Is that satisfied? 1,800? No, it has to be at least 2,500. So that one's out. 4 masters and 8 apprentices. 4 masters, 8 apprentices. 4 masters gives me 2,000 for the wall and 400 for the trim. 8 apprentices gives me 800 and 800. So that's 1,200 and 2,800. 2,800 is 5 and 1,200 is fine. It's good. So this one is true. It's only those 3. I don't know if there was more missed off, but C works for that. Okay. And that looks like that's all that was copied down there. Okay, that does it. What was the time of that one? 47 minutes.